Lorentz developed the equations needed to show precisely how much rulers would have to contract and clocks would have to slow down when they were in motion. The essence of his reasoning can be seen with the aid of the simplest possible clock. Two mirrors a fixed distance apart, with a light beam bouncing back and forth between them. Each bounce of the beam is a tick or a tock of the timepiece. To Henry, his clock is stationary and altogether ordinary. But for Albert, that clock is moving. And between tick and tock, he sees the light beam trace a diagonal path, which means it's traveling a longer distance. But the speed of light is the same for all observers, so the light must take a longer time to travel the longer distance. Therefore, Albert believes the moving clock runs slow. But how slow?
The relativity of time is derived from the right triangle formed by the distances traveled. The Pythagorean theorem shows that the path of the moving light is longer than the distance between mirrors. By the factor 1 over the square root of 1 minus v squared over c squared. This factor occurs so often in relativity that it is given its own symbol, the Greek letter gamma.
So to an observer at rest, a moving light clock seems to be running too slowly by the factor gamma. A ruler, or anything else in motion, also seems contracted by that same factor.